A differential equation is an equation that has a function and its derivative. So we have y and dy dx in the equation, or we would have p and dp dt in the equation. So a function and its derivative. This question says find the general solution to the differential equation. When we're solving a differential equation, we're going to get it just in the form y equals. So we're going to get rid of the derivative. We do that by splitting it up. So here we've got dy dx equals 3xy. So we're going to get the y's on one side, the x's on the other side, and the y's are going to be with the dy, and the x's are going to be with the dx. So if we times both sides by the dx, we'll get dy equals 3xy dx. Divide both sides by y, so 1 over y dy equals 3x dx, and we integrate both the sides. So we've got the y's on one side, the x's on the other side, and then we're going to integrate both sides. So the integral of 1 over y with respect to y is log y. The integral of 3x with respect to x. So add 1 to the power, divide by the new power, and then we're going to plus a c. We don't have to plus c to both sides. We only need one c, because if you've got a constant on both sides, you can have one constant, take away the other constant, and it just leaves you a constant. So we haven't been asked to give our answer in a certain form, so I'm going to leave it as that. So that is the general solution to the differential equation. It's general because we've still got the plus c in it. If we wanted a particular solution, we would have to have a value of x and y to substitute in and find c. One for you to try, see if you can give it a go. So again, we're going to find the general solution to the differential equation. We're going to get the y's on one side and the x's on the other. So we're going to times by y and times by dx. So we're going to have y dy equals 2x dx, and integrate both sides. So integrating y with respect to y, add 1 to the power, divide by the new power. Integrate 2x with respect to x, add 1 to the power, divide by the new power, and plus a c. And again, we're not asked to give it in a certain form, so we can leave our answer as this. In this question, we are asked to find the particular solution to the differential equation, x squared dy dx equals x plus xy, when x is 1 and y is 2. So this time we can find out what our constant is. We don't have to have a plus c in our answer because we've got an x and a y that we can use to find the c. So that's why it's a particular solution, not a general solution. We solve it in the same way. We split the x's and the y's. So we're going to get the y's to the left and the x's to the right. We will firstly have to factorize the right side. That's going to be x times 1 plus y. So then we want all the x's on the right and all the y's on the left. So we're going to divide by 1 plus y. We'll have 1 over 1 plus y dy. For our x's, we're going to divide by x squared. X over x squared is 1 over x, and the dx times is to the right side. So we've split the x's and the y's. The y's have all moved left. The x's have all moved right. So we've got 1 over 1 plus y dy equals 1 over x with respect to x. Now we can integrate both sides. When we have a power of -1, we get a log. So both of these are going to be logs. We're going to get log 1 plus y equals log x plus a constant. When we have just logs in our question, we can change our constant. Instead of c, we can write it as a log c or a log k. So now everything's in terms of logs. We can eliminate the logs. So we're going to use the rules of logs. Then we have two logs added together. We times the big numbers, the arguments. Log x plus log k is log kx. So now both sides have got a log. We can eliminate them. It's just 1 plus y equals kx. And then we can substitute in x is 1, y is 2, and find out what k is. So when x is 1 and y is 2, we're going to get 3 equals k. So k is 3, which means our answer is 1 plus y equals 3x. Or if we write it in the form y equals 3x minus 1. Okay, one for you to try. See if you can give this one a go. So again, we're finding the particular solution to the differential equation. That means we're going to find c as well. The first step, solving a differential equation, we're going to split the y's onto one side, which is going to be the left side with the dy. The x is going to be on the right side with the dx. If we divide by y, we get 1 over y dy, and then times the dx up, 1 over x plus 1 dx. And we integrate both sides. 1 over y integrated with respect to y is log y. 1 over x plus 1 integrated with respect to x is log x plus 1. And we plus a c, but I'm going to plus a log k because that's going to help me eliminate the logs. So we've got log y equals log k times x plus 1. Now we can eliminate those logs. There's a log on both sides. So if log y equals log k times x plus 1, y must be equal to k times x plus 1. When x is 5, y is 3. So 3 equals 5 plus 1, so 6k. K is a half. So our answer is y equals half of x plus 1. Another question, find the general solution to the differential equation dy dx equals y over cos squared x. Again, we're splitting x's and y's. So I want the y's with the dy, so the y's are going to be on the left. So divide by y. And my x's are going to be on the right, 1 over cos squared x dx. 1 over cos squared x is sec squared x, which we know how to integrate. So I'll change that before I integrate. Now we just need to integrate both sides. The integral of 1 over y with respect to y is log y. The integral of sec squared x is tan x, and we plus a c. Find the particular solution when x is pi over 4 and y equals 2. So we're going to substitute in pi over 4 and 2 and find out what c is. So we're going to get log 2 equals tan pi over 4. Tan 45, tan pi over 4 is 1 plus c. So c is log 2 take away 1. So we can just put that back in and say log y equals tan x plus log 2 take away 1. And we haven't got to give our answer in a certain form, so I'll leave it like that. And there's one for you to try. See if you can give it a go. So we're going to take the y's to the left side. So it's going to be y dy. And we've got the integral of x times ex with respect to x. We've got two things multiplied together on the right side. So we're going to be using integration by parts. Where can I write it? The integral of u dv dx with respect to x is equal to uv minus the integral of v du dx with respect to x. So we're going to pick something to be u, which is going to be our x, because when we differentiate it, it's going to go to 1. So we're going to say u is x, dv dx is e to the power of x, which makes du dx 1, and v e to the power of x. So integrating now, the left side, add 1 to the power, divide by the new power, we get half of y squared, and that's going to be equal to our integration by parts, which is uv x e to the power of x minus the integral of v du dx, which is e to the power of x with respect to x, and the integral of e to the power of x is e to the power of x. We've got half y squared equals x times e to the power of x minus e to the power of x plus a constant. Part B, find the particular solution when x is 0 and y equals 2. So substitute them in. So we've got half of 2 squared equals 0 times e to the power of 0 minus e to the power of 0 plus c. So half of 2 squared is 2. 0 times e to the power of 0 is 0. Take away e to the power of 0, which is 1, so minus 1, negative 1 plus c. So c is 3. So we have our answer, half of y squared equals x times e to the power of x minus e to the power of x plus 3.